Rahim. Assalamu alaikum, dear students. This is our next problem. Problem having been once again chosen from the same book, Modern Physics by Kenneth S. Crane. This problem is about stopping potential, about determination of Planck's constant, about determination of work function of sodium. Dear students, in this problem we are required to find out two things, and both things are physical constants and are given in every textbook of physics in table of physical constants. Okay, we know that value of Planck's constant H is constant and is given in many tables. Okay, similarly, value of work function of sodium, whose name in table of elements is denoted by Na, okay, is also given. So both things are well known, are very, we can say, famous, popular, known publicly, but here we are required to recheck those quantities or find out those quantities only with the help of data which is provided in this problem. Okay, so as usual, first we come towards statement and then we will come towards helping tools and then we will come towards calculation. Okay, when sodium metal is illuminated with light of wavelength 4.20 into 10 to power 2 nanometer. 4 into 10 to power 2 means 420. Okay, so 420 nanometer is a simple thing. Okay, while we are a little confused by this pattern. Okay, 4.20 into 10 to power 2 into 10 to power minus 9 meter. Alternatively becomes 4.2 into 10 to power minus 7. Okay, or 420 into 10 to power minus 9, that is nanometer. Okay, when sodium metal is illuminated with light of wavelength 4.20 into 10 to power 2 nanometer, the stopping potential is found to be 0.65 volt. When the wavelength is changed to 3.10 into 10 to power 2 nanometer, here again 310 nanometer is easier to describe. Okay, and we are a little confused by description of this quantity in this irregular form. Okay, 3.10 into 10 to power 2 nanometer means 310 nanometer. Okay, or we will write it as 3.10 into 10 to power plus 2 into 10 to power minus 9 meter, and this will come to result 3.10 into 10 to power minus 7 meter. Then the stopping potential is 1.69 volt. Using only these data and the values of the speed of light and the electronic charge, Okay, dear students, these two values are also constants. Okay, using only these data and the values of the speed of light and the electronic charge, find the work function of sodium and a value of Planck's constant. So student, the values which we are required to determine are already given in tables. Okay, but despite this, we are actually required to adopt a proper mechanism to reach this quantity properly. Okay, now we come to its helping tools. Okay, dear students, this is first helping tool. Okay, helping tool number 1, in this table speed of light is a constant 2.998 into 10 to power 8 meter per second. Okay, moreover, Planck's constant, we have to find out this value, Planck's constant H, which is already given in this table in two different systems. Okay, in joule second as well as in electron volt second. Okay, so answer is given in this table, but we are required to find out this value, that is 4.136 into 10 to power minus 15 electron volt second. Okay, one thing we are required this, and the other thing required is work function for sodium Na. Okay, now we move to next tool. Yes, this is the tool. Okay, in this tool, dear students, we can see that photoelectric work functions of various materials or substances or elements are given, in which top of the list is sodium Na. Okay, its work function is 2.28 electron volt. Okay, it is denoted by phi. Okay, so answer is given. Two answers which we are required to calculate with to reach are given in these two tables. Okay, okay, number 1 we have to calculate this value, Planck's constant. Okay, this. Okay, and second we are required to find out this value, that is photoelectric work function of sodium. This is Na is name for sodium. Okay, whose work function phi is 2.28 electron volt. Okay, anyhow, let us introduce another tool. Okay, the other tool is photoelectric effect. Okay, in which E into V naught, this is the maximum kinetic energy of photoelectron, in which in E and V naught, E is the magnitude of electron charge and V naught is the stopping potential. This quantity is alternatively equal to Hf minus phi. Phi means work function. Okay, what is H? H is the frequency. H is the Planck's constant, F is the light frequency. Okay, H is the Planck's constant and F is the frequency, and Hf combinedly is the energy of absorbed photon. Okay, minus phi is the work function. Okay, once again, EV naught, that is maximum kinetic energy of photoelectron, EV naught, where E is the magnitude of electron charge and V naught is the stopping potential, is equal to Hf minus phi, where H is the Planck's constant, F is the light frequency, phi is work function. Okay, and Hf is the energy of absorbed photon. Now we come towards its solution. Okay, we know that maximum kinetic energy of photoelectrons is given by K max, where max is written as a subscript of K. K stands for kinetic energy, is equal to E into Vs. E is magnitude of electron charge and Vs is the stopping potential. Potential is denoted by V and hence stopping potential is denoted by Vs, is equal to Hf minus phi is equal to Hc over lambda minus phi. Okay, because we have already mentioned many times that frequency and wavelength are reciprocal of each other with the involvement of speed of light. Okay, so f is equal to c over lambda and lambda is equal to c over f. Okay, where Vs is the stopping potential. This implies that EVS is equal to Hc over lambda minus phi, equation number 1. Okay, this is just rearrangement or reproduction of above equation in a relatively short manner. Okay, now in accordance with given data, equation number 1 takes the form as, dear students, in this equation which values have been given. Actually we have been provided with two sets in problem statement. Okay, one wavelength and one stopping potential. Okay, both these values are given twice. That is to say, we have been provided by two sets of values. So this is the main equation which we are required to follow, and we will put one by one these two sets of quantities in this equation. Okay, equation number 1. So this equation number 1 is now being transformed in equation number 2 and 3, because we have been provided two sets of quantities. Okay, one by one we will put one set one time, and equation number 1 will be transformed into equation number 2. Then we will put other set of quantities and equation number 1 will be transformed into equation number 3. Okay, so dear students, here stopping potential, one stopping potential given was this, and corresponding to this stopping potential wavelength given was this. Okay, 4.20 into 10 raised to the power 2 into 10 raised to the power minus 9 meter, or in other words 420 nanometer. Okay, this quantity can also be written as 420 nanometer. 420 nanometer. Similarly, among in second set of quantities, stopping potential has been provided as 1.69 electron volt, while corresponding to this stopping potential wavelength given is 3.10 into 10 to power 2 into 10 to power minus 9 meter. This is equivalent to 310 nanometer. Okay, so it is just our discretion whether we write this wavelength in this form, or we write it in the form as 4.2 into 10 to power minus 7 meter, or we write it as 420 nanometer. Similarly, about this wavelength, it is our discretion whether we write this wavelength as 3.10 into 10 to power minus 7 meter or 310 nanometer. Okay, so from equation number 1 we have got two further equations. Okay, by using those four values. Okay, first two values in equation number 1 and then second two values in equation number 1. So we have got equation number 2 and 3. Here dear students, we will subtract equation number 2 from equation number 3. What will be the outcome of this operation? Outcome of this operation will be that we will get free from this factor, that is work function. Okay, if we subtract, actually dear students, equation number 3 is greater. In equation number 3 stopping potential is greater than stopping potential of equation number 2. So we will subtract equation number 2 from equation number 3, so that our stopping potential becomes positive plus. And second benefit of this subtraction will be that work function phi will be cancelled out, eliminated. Okay, so subtracting equation number 2 from equation number 3, we get 1.69 electron volt minus 0.65 electron volt is equal to this quantity. Okay, Hc over 3.10 into 10 to power minus 7 meter minus Hc over 4.2 into 10 to power minus 7 meter. This implies that when we subtract these two stopping potentials, we will get 1.04 electron volt. And on the right side, we take Hc common. When we take Hc common from both sides, then we will be left with 1 over 310 nanometer minus 1 over 420 nanometer. Okay. In next step, we will take LCM type arrangement. Okay, we will multiply both in the denominator, and hence in the denominator we will get 420 nanometer minus 310 nanometer. Okay, this will reduce to 110 nanometer divided by 130200 nanometer square. Okay, by multiplying 310 with 420, we will get this figure. Okay, 130200 nanometer square. Dear students, here 1 nanometer will be cancelled from 1 nanometer, while 1 nanometer in the denominator will remain. Okay, so this expression will take the form as 1.04 electron volt is equal to Hc into 8.45 into 10 to power minus 4 into nanometer raised to the power minus 1. That is to say, in other words, we can also write it as per nanometer. Okay, nanometer is in the denominator. So from here, this implies that H is equal to this over this. Okay, into this. What we have done, simply we have kept H on one side and shifted all other on other side, shifted all other things on other side of the equality. Okay, so H is equal to 1.04 electron volt divided by C into nanometer, because here nanometer is raised to the power minus 1, but after being shifted on other side of equality, this minus 1 will be converted into plus 1. Moreover, this 10 to power minus 4 will be converted into 10 to power plus 4 after being shifted on other side. Similarly, 8.45, which is being multiplied here, will be divided on the other side of equality. Okay, so dear students, no further need for such minor steps which we are dealing with since primary or middle level. Anyhow, H becomes equal to 0.041 into 10 to power minus 13 electron volt second into second. But dear students, we know, we have mentioned this thing many times, that 10 to power minus 13 is not appropriate for us in terms of physical quantities mostly used in physics. Okay, what power is more suitable for us is 10 to power minus 12 or 10 to power minus 15. Okay, so in place of 10 to power minus 13 we will convert it into 10 to power minus 15, so that it may fall under the term femto. Okay, femto is 10 to power minus 15, pico is 10 to power minus 12, nano is 10 to power minus 9, micro is 10 to power minus 6, milli is 10 to power minus 3. Okay, so dear students, here value of Planck's constant H has become equal to 4.1 into 10 to power minus 15 electron volt second. Dear students, if we compare this value with the value given in table, we come to conclude this is almost exactly the same value. The only difference is that here we have taken only one digit after decimal. After decimal, only one digit has been selected, while if we move to table, we will find that it is up to 4 digit. Okay, yes, this is the value 4.136 into 10 to power minus 15 electron volt into second. Okay, exactly same value we have reached. The only difference is that we have worked up to 4.1. We have not yet calculated 3.6. So our 4.1 will be assumed as 4.100. Okay, so I think this is not very important. We have reached almost same value, exactly same value. Okay, now we come towards other part in which we have to find out work function, and work function has also been given in the table, which is 2.28, but we have to confirm this value. We have to recheck this value, counter check this value by the data provided in this problem. Okay, in this problem 4 quantities have been provided, and we are advised that in addition to these 4 quantities, 2 physical constants, that is speed of light and electronic charge, are also known from table of physical constants. So in the presence of these 6 values, we have to find out these 2 values which are again given in tables, but we have to just confirm our result, that our result whether tallies or not. Okay, so anyhow, dear students, here once again we will return to our first equation from where we started. Equation number 1 gave birth to equation number 2 and 3. Okay, and now in this part of this problem solution, we are going to transform equation number 2 and 3 into 2 further equations. Okay, that is to say, equation number 2 is going to be transformed into equation number 4, and equation number 3 is going to be transformed in equation number 5. Okay, so let us see how this is happening. Rearranging equation number 2 and equation number 3 as this equal to this. Okay, similarly this equal to, similarly this arrangement will also be made for equation number 3. Okay, first we come towards equation number 2. This is equation number 2. From here, dear students, what we have arranged, actually we have made such arrangement that this denominator is multiplied with this factor, okay, and then this is transferred on other side of equality, and then this will be multiplied with this. Okay, similarly in question number 3, this factor in the denominator will be multiplied with this factor, and after this it will be transferred on other side of equality, and hence it will also be multiplied with this. Okay, so this is the arrangement due to which equation number 4 and 5 have come into being. Okay, 0.65 electron volt into 420 nanometer is equal to Hc minus 5 into 420 nanometer. Okay, that is to say 420 nanometer was in the denominator, and now 420 nanometer has also been multiplied with this potential, stopping potential, as well as it has also been multiplied with work function. While this 420 nanometer was originally below this Hc. Okay, so this is just a rearrangement, nothing else. Hence, dear students, what we have done here? We have done here that we have shifted 5 cross 420 nanometer on other side, so that it has become positive, and this quantity has been shifted to other side, so that it has become a minus. Okay, no rocket science. Okay, quite simple. Now Hc is equal to this plus this. Quite simple. Hc becomes equal to this. Okay, equation number 4 has come into being. Okay, similarly now we are dealing with equation number 3, which will be transferred into equation number 5. Okay, this equal to this over this. This factor will be multiplied with this factor. Okay, then this factor will be multiplied with this factor. Okay, in other words, we will take LCM this, and hence Hc minus this into this, and in the next step this factor in the denominator will be shifted on other side of equality, and hence Hc is equal to this plus this. This implies that Hc is equal to this. Okay, equation number 4 and 5. Okay, just rearrangement, nothing else, just rearrangement. Now the thing which has become simple for us is that equation number 4 is also value of Hc, and equation number 5 is also value of Hc. So equation number 4 and 5 are equal. So here it has become possible for us to eliminate Hc. Okay, when we will take value of Hc, this is equal to Hc and this is also equal to Hc. So when left hand sides of equation number 4 and 5 are equal, then definitely right hand sides of equation number 4 and 5 are also equal. So we are just equating right hand sides of equation number 4 and 5. Okay, equating equation number 4 and 5, we have this equal to this, so and so and so and so. Okay, so here, dear students, work function phi for sodium Na has become equal to 2.28 electron volt, which is 100% same which is being shown in our tool, in which a table is being shown in which photoelectric work function of various substances or elements has been given, and at the top of that table sodium comes at serial number 1. Okay, so this is the end of our problem. Till next video, Allah Hafiz.